So when you're dealing with integrals of trigonometric functions with linear function, you need to be able to identify that linear function. That linear function is usually inside these brackets over here. So you might want to say, well, where is that linear function? As you remember, the linear function usually looks like mx plus c, or in this case we'll call it y is equal to ax plus b. It doesn't matter. What's important is the fact that you have an x in here and an x in here. And that means what we're looking is for the coefficient of x. In this function over here inside the brackets, does this function resemble a linear function? You might say, well, yes, it does. If I rearrange it, I'll show you that it looks like this: a half x plus 0. Or just assume that it is 0. So in this case, our coefficient will be a half. This will represent the a value here, and of course the x value still stays here. So you may wonder, why I'm making such a deal of this linear function. Well, let's have a look at the integral of a trigonometric function rule. As you can see, the linear function over here, we need to take out the a value and use it as 1 over a. So by rewriting my integral again and saying 3 cos a half x dx. For our purposes, the 3 really can be taken outside of this integral, and we can start again. Cos half x dx. So now we can start integrating, and notice that the half is now our a, and we will put it 1 over a. Remember that our constant comes first, and now we can start integrating. So it'll be 1 over a half, and then the cos becomes a sine. So let's make that cos sine half x. And we'll just add the c to the end because that's what we usually do. And now you can see how awkward that 1 over half is. So we really need to be able to turn it around and say 1 over a half is 2. So that means we're doing 3 multiplied by 2. And start sine a half x plus c, which just ends up being 6 sine a half x plus c. In this next example, the same process applies, but this time we're going to use the formula for sine. First of all, as before, we just want to identify that value linear function and identify the a value of it. Well, in this case, we could rewrite this as minus x plus pi on 4, where in that case our a value is going to be minus 1. So with that in mind, let's start first of all getting the minus 3 out of the way by putting it in front. So just rewriting this down one more time, we'll have minus 3, integral again, this time it is sine, and pi on 4 minus x. Now we can actually integrate properly. So leaving the minus 3 out and dividing 1 by minus 1, and then changing the sign to a cos, but it has to be minus cos, okay, of pi on 4 minus x, and ending off with r plus c. And we ended up with 3 negative signs over here, so that'll all end up being just one negative sign. Negative by negative is just negative. 3 and cos pi on 4 minus x plus 3.